All right, let's jump right in. We think of our immune system as our body's ultimate protector, right? This sophisticated little army inside us, fighting off invaders 24/7. But what happens when that army gets the wrong orders?
What if this incredible system that's designed to keep you safe, the one whose whole job is telling the difference between friend and foe,
What if it suddenly declared war on itself? This isn't some plot from a sci-fi movie. It's a very real biological phenomenon known as a cytokine storm. And frankly, it's one of the most dangerous situations the human body can face.
So today, we're going to explore what happens when the immune system's communication network just completely breaks down, turning a coordinated life-saving defense into absolute system-wide chaos. This is pretty much the story of the body's own civil war.
So let's start with the big one, a cytokine storm. The easiest way to think about it is this. Cytokines are kind of like the text messages of your immune system. They send out little targeted instructions. But in a cytokine storm, it's like every immune cell starts spamming the group chat with "attack" in all caps, over and over. This leads to a massive, uncontrolled inflammatory response that can actually cause your organs to start shutting down. Now, under that big umbrella, there's a more specific type you should know about: cytokine release syndrome, or CRS. The weird thing about this one, it isn't usually caused by an infection. It's often caused by us, by really powerful medical treatments like CAR T-cell therapy, where we supercharge our own immune cells to go fight cancer. Sometimes they just get a little overzealous.
So, to keep it simple, all cases of CRS are cytokine storms, but not all cytokine storms are CRS. It's like how a square is a rectangle, but not all rectangles are squares. One is the general, massive problem of hyperinflammation. The other is a specific version that's often triggered by our own medical ingenuity. And for doctors, that's a really critical distinction.
Okay, so if a cytokine storm is the terrible destination, what are the different roads that can lead to it? Well, it turns out several different things can ignite this internal fire.
And you can see a few of the main paths here. You've got genetic conditions like HLH, where the immune system basically lacks an off switch from birth. Sepsis, that life-threatening response to infection, is a classic trigger. Of course, we all became way too familiar with this during the COVID-19 pandemic, right? Where for so many, the virus itself wasn't the direct killer. It was the body's over-the-top reaction to it. And then there's stuff like toxic shock syndrome, where bacteria basically hotwire millions of your T cells at once, causing a huge immediate cytokine dump.
So, this massive storm is raging inside the body. How do doctors on the outside even know it's happening? Let's look at the clues they're searching for.
No matter what the trigger is, the initial signs often look a lot like severe sepsis. A high persistent fever is almost always the first clue. From there, the damage just spreads. The lungs can fill with fluid, leading to severe respiratory distress. Blood vessels get leaky, causing blood pressure to just plummet. The inflammation can even cross into the brain, causing confusion and lethargy. It really is a total systemic breakdown.
And while the core features are similar, different triggers tend to leave their own unique fingerprints. For instance, in that genetic condition HLH, doctors often find an enlarged liver and spleen. With toxic shock syndrome, a classic sign is a rash that looks a lot like a sunburn. And in severe COVID-19, widespread blood clotting was a devastatingly common complication. These little details are the clues that help doctors pinpoint the cause.
To really confirm their suspicions, doctors turn to blood tests. They're looking for these massive spikes in inflammatory markers, things like CRP and ferritin. You can think of these as the biological smoke signals that prove a fire is raging. They'll also see chaos in the blood counts, with platelets just plummeting, and clear signs of organ damage, like elevated liver enzymes. This is the hard data that proves the storm's intensity.
Okay, so the storm has been identified. The clock is ticking. What can you possibly do? How do you stop a body from destroying itself?
The strategy is basically a two-pronged attack. It sounds simple, but it's incredibly difficult in practice. First, you have to calm the storm itself. You've got to suppress that out-of-control inflammation. And second, you have to go after whatever triggered it in the first place, whether that's an infection, a faulty gene, or a reaction to therapy.
And here are the tools they use to do it. You've got cytokine blockers, which are incredibly precise. They're like communication jammers, specifically blocking one of those attack messages. Then you have broader stuff, like glucocorticoids, which are the heavy artillery. They basically tell the entire immune army to stand down. And in some of those genetic cases, the only real long-term cure is a stem cell transplant, which is essentially a complete reboot of the entire immune system.
When you really think about it, This whole phenomenon shows you a profound truth about our biology. The very same power that protects us from countless threats every day also has the capacity to destroy us. Our body walks this incredibly fine line between powerful defense and total self-destruction.
And this all leaves us with a really fascinating question for the future. We're getting better and better at unleashing the immune system to fight diseases like cancer. But as we hand it more powerful weapons, maybe the great challenge ahead isn't just about making it stronger, but about learning how to be its master, learning how to truly command the storm.